job.
Okay, cheers. Thanks for Republic of Work, Cork Dev, and Nginx for tonight. I like the new digs. So I don't have as much live coding as Peter, but I have some, so bear with me. So today I want to talk about property-based testing, which is a testing technique that we use at NewsWeaver. I'm a software developer at NewsWeaver. I'll spare you the spiel because there are like 10 people from NewsWeaver. You can talk to them. So why do we care about tests, right? And why do we care about unit tests? So we care about unit tests because you can use them to guide development. They provide early feedback about the system under test to its stakeholders. So stakeholders being the end users or the developers themselves. And we can't automate everything, but unit tests lend themselves to automation pretty well. Okay, and whether or not you subscribe to the TDD approach, or whether you just write good unit tests after the fact, you write unit tests because you want to increase your confidence in the smallest components of your system. So here you've got a picture of the infamous O-ring that caused the space shuttle to explode. So it was narrowed down to this tiny part that caused the whole disaster. And that can happen in code as well, right? So you want to make sure you want to increase your confidence that even your smallest components do what they're supposed to. And actually, your unit tests define what it works means, right? So you use them as executable specification. And also, they act as a they're able to detect change. If they're good, they'll detect change in behavior. If you change the implementation, if you made changes in the implementation that change behavior, your unit test should tell you, right? The thing is, most of our unit tests, I'm guessing most of the unit tests you write are example-based. So what I mean by that is that we tend to use somewhat arbitrary values in our test cases, right? Why? So in this case, I want to assert that factorial 1 is equal to 1, right? But I'm sure all of you can think of, random, or well, I shouldn't use the term random actually, but you came up with your own test data, and you if you had a person, you call him Homer Simpson, and you came up with your own arbitrary values for your test cases. Okay, so that's what I mean by example-based tests, and we'll see in a minute what how property-based testing is different to that. But first of all, I deliver to you the 7 deadly sins of example-based testing. I don't know if you've seen the craze about the 7 deadly sins of this, the 7 deadly sins of that, microservices, GraphQL, whatever. You can't get away from it, so that's my turn. Okay, so there we go. Lust, so you've got a bunch of test data. I don't know, maybe it's in a folder, maybe it's in the test class. And after a while, first of all, you don't enjoy really writing that. Maybe at the beginning, Homer Simpson, but it gets old very quickly. So you end up, your test cases start using that test data. They all start using the same test data, and you end up with a lot of coupling between your test cases. Not between the tests themselves, but because they use the same test data, you've got some coupling there. And maybe you realize you need to add a new test case or something, and you realize, oh, I need this particular test data to be slightly different. Do I create more test data? How do I get away from that? So you get some coupling, and in a way, it hurts your code's ability to evolve, right? So that's for lust. Gluttony, so You want to do things right, but you end up with too many test cases, a bloated test suite, screens and screens of tests, and it's kind of tedious to trawl through, to read, write, maintain, so you don't want that. Greed, I guess you can get that whether or not you do property-based testing or example-based testing, but you can become slave to your coverage metrics. So maybe in your company you get a threshold and you need to be at 95% or else, right? And code coverage doesn't indicate that your testing is appropriate. It doesn't say that your assertions are sound. It doesn't say that. It only says that your test code exercised that much of the production code. Sloth. So you've given up. Either the system is too hard to test, or you don't have enough time. So you don't have you have few to no test cases, and your tests actually lack imagination. So you don't explore the interesting values, the edges, the interesting situations. You've pretty much given up. So the lights are on, but no one's home, pretty much. Okay, example time. So if I can bring IntelliJ. So in relation to what I was talking about there, if you're not careful, you can actually miss serious edge cases, right? You may not realize it, and you may have 100% test coverage, but you're still missing edge cases. And here's an example. So I've got a very simple function that I'd like to implement. This is Scala. I'll try to make this talk language agnostic, but here's an example in Scala. So we've got a partitioner class, and when we construct it, we say, you're gonna have that many partitions, and it has one method, and that method takes any int, and returns an int between 0 and the number of partitions exclusive. Okay, so if I've got a three-way partitioner, if I give it any int, a sign is going to return 0, 1, or 2. Okay. So how would you implement that? And you don't need to know Scala to give an answer. So we need to take any int and return between 0 and the number of partitions, but not the number of partitions. So one way, I don't know about you, but I'm very tempted to take the modulo or something. Okay, so I take my int, and I take the modulo of the number of partitions. And that's not going to work because n can be negative. So if n is negative and I take the modulo of a negative number, I'm going to get a negative number. So how about we take the absolute value there? Okay. Okay, does that look okay? Does that look reasonable? Yeah. And then I've got, where am I? Okay. So, and also, when I construct, this is the constructor pretty much for my class. I want to reject a non-positive number of partitions. It doesn't make sense for a partitioner to have 0 or less or fewer partitions. It has to be 1 or more. Okay. So I'm going to have some kind of assertion. Require number of partition to be positive. And so this thing is going to throw an exception if that condition isn't satisfied. And if we get past that, then we construct and we return a partitioner with the the desired number of partitions, okay? So that's fine. Now, I've written some tests for this. Okay. And I think those tests look pretty fine. Let me just, I'd like to know all the IntelliJ shortcuts. That really, I'm being betrayed by my lack of knowledge of IntelliJ. But anyway, so I think, so I'm capturing the two requirements. So if I feed a non-positive number to my constructor, I get an exception. And the second test that I have here is assign. My assign function should always return a number between 0 and the number of partitions. Okay, so let's try and run that and see what we get. Does that look sensible to everybody? Looks fine. Okay. Oh no. Okay. Okay. Is it running? Happy days. Okay. Everything passes. But there's a bug in there. Does anybody know where it is?
Greater than or equal to? Is that supposed to be just greater than 0? No?
No. So just trust me on this. There's a bug in there. Okay. We'll go back to the. Okay. I'm lost. Oh yeah. Sorry?
Is it the absolute, the mathematical absolute, is correct or canonical or whatever Java or Scala absolute has?
Get out. You're spoiling it. Yes, it has to do with the absolute value. So let me just finish 7 deadly sins of example-based testing. So another one related to sloth is the tests. You've given up. So you've given up on describing the test properly. So you're calling the test methods, or you're writing the test descriptions, or test 1 or test 2 or whatever, right? And then the next guy inherits your code base and the test suite as well, and it's like, I don't understand what this is doing. Wrath. So at this stage, you probably understand that my 7 sins is slightly contrived, but so you've written your test cases properly, and you have a good description, but you still only have one executable scenario. Okay, only one test case for each behavior that you're trying to test. Okay, and then your reader might be left to infer what the meaning of those particular values are, and he or she may be in a position where he or she has to connect the dots. And you might be tricked that some of the values that you're using in your examples have some value, but that's not the case, so it may lead you into wrong assumptions about the behavior that you're actually describing. The description of the test might describe the behavior, but in the end, the test code is the ultimate truth, right? Envy, we're almost there. So sometimes you'd like your test cases to be, your test suite to have a size that you can tune. So on your local environment, maybe you only want to run a limited number of cases, but maybe overnight you want to run thousands of them, right? And if you're using example-based testing, or if you have example-based tests, you can't do that automatically. You have to write those tests, right? You don't have a choice. I think that's the last one. So you're having fun with your test data. So as I said, Homer Simpson works at Springfield Nuclear Station, blah, blah, blah. And it's fun at the beginning, but again, you're not thinking about the next guy who's going to inherit the test code. And you might get a few laughs, but you're actually distracting from what you're trying to achieve, which is increase your confidence in the system and the test, right? Okay, you see, yeah, okay. That was expected. So I don't know if you can see this clearly, but loads of test data, pretty uninteresting. That's what I was talking about. So we want the tests, we want our test suites at any level, really, any level of testing, to pull their own weight, okay? We want to get value out of them. We don't want them to become a liability. So property-based testing to the rescue. This is John Hughes. I think it was mainly active in the Haskell world originally, but he's mostly working with Erlang at the moment, and he's the guy who came up with the idea of property-based testing. And his leitmotif is don't write tests, generate them, okay? So what is the meaning of property in property-based testing? So I'm not referring to the first meaning in there. I'm referring to the second one. So a property is an attribute, a characteristic of something. So when you're going to write properties of the system and the test, and those properties describe general behavior of the test. Okay, they define what it is or what it's supposed to do. And so you write those properties and you give them to the testing tool. In this case, it's called Scala check, sorry. And that testing tool is going to try to hammer it with random inputs, okay? So those properties are pretty much parameterized tests, and the library is going to generate random inputs and try to falsify those properties, okay? If it finds a counterexample to your property, a bunch of values for which your property fails, then you know that something's wrong. If everything passes, you can't know for sure, but you have increased level of confidence. Okay. So how do you generate those random values? If you're using very simple values like strings, so I'm talking about specifically in Scala, where you do have types at compile time, but so if you only need strings, ints, all of that, the testing library provides generators that are responsible for generating those random values. But if you want to generate values for your own custom types, then you can just assemble generators, because Scala, everything is compositional, so you can build your generators out of smaller ones that the library gives you. And then that's not the end of it. If the library finds a counterexample, if it finds a value for which your property is falsified, then it's not going to tell you this is the value that makes your property false. It's going to try to simplify it, shrink it, so that it's more palatable, okay? And you can actually see immediately what's wrong. So I'm using this in Scala. I've used it a bit in Haskell, but not that much. But pick your favorite language. I actually had a look at Golang, but I only saw a couple of blog posts, so I'm not entirely sure whether there is a library for that. Maybe you know more about that.
So Go false, which is in there.
Okay.
It's not exactly the same concept.
Okay. Go false. So yeah, so if you use another language to Scala, like a different language to Scala, you can probably still find a library that does that. So let's revisit the example. Okay. Where am I? So now I'm going to show you the same tests or the same behavior that I'm testing, but written as properties, okay? Okay, so here I'm saying same thing. If the number of partition is non-positive, then throw an I expect that code to throw an exception of type illegal argument exception. And you see, there is no particular values. Everything is abstract, okay? I'm not using -1 like I did in my example-based tests. I'm saying for all non-positive integers, if I use that as the number of partition, then I'm going to get an exception. So you're raising the level of abstraction of your test suite already, okay? And then the other one is pretty much the same thing, but again, I'm not using any particular values. I'm saying for all valid partitioners and for any integer, this is what I expect, okay? And what's at the bottom there is just, I've defined custom generators because I needed, or maybe it's just to get, to make the test or the properties more readable. Yeah, go on.
The assembly doesn't come up with absolutely every non-negative value. It takes a subset, right?
So the library, the testing library, yeah, it's so by default, if I run the test there, it's gonna generate 100 random values. And the library, like the generators that come with the library, are clever enough to try interesting values. So it's gonna try, 0, -1, minimum value of ints, maximum value of ints. But I just have to change one parameter, and you could generate more random cases. It's not going to do an exhaustive check on all the possible values. That would probably be prohibitive. But even by randomly generating values, you can still increase your confidence that your system is sound, right?
Is it like if I choose 100 values?
Yeah.
Is it going to be deterministic, and the next time I run it, it'll use the same 100 values? Nothing's changed?
No. So the tests in that respect are non-deterministic. I'm not sure whether you can provide a seed. Maybe you can do that in Scala check. I've never done it. I don't know about other libraries, but in that respect, they're non-deterministic. So I would say, have many generate at least 100 as a rule of thumb. Because yes, if you just generated one, you might get past, and yeah.
If it fails, it's going to tell you what values.
Yes, yeah. So if I can find my pointer, I might try and run this. Okay. Cool. Okay, so it's failing. The second one is failing. The first one is fine. The second one is failing. Does anybody recognize that value? That's the integer. That's not the number of partition, but that's the integer that I feed to my assigned function. What's that value? Huh? Yeah, it's the minimum value. It's the low end of the int range. Sorry. And so this may be surprising, but if you actually go back to effective Java, and I mean that's where I learned it from, but item 47, Josh block tells you the absolute value returns a non-negative number, except in this case, because that's the end of the range, and if you try to get the absolute value of that, you wrap around and you go back to that original. So arguably, you could say, that's just one value. It fails for one value, it's fine for all the rest. But imagine having, maybe you're using this partitioner a lot. Maybe you're using it to publish events to partitions in Kafka, and you get loads of events, and all of a sudden you get this. That could be very surprising, and you might spend a lot of time trying to find the root cause, and you might as well save yourself the trouble now, as opposed to having to debug this in production. Okay. Okay. So back to the slides.
That's not what I thought it was.
This is tricky. Oh, boo.
Is that considered a bug in Java, or is it a feature?
It's a feature, like.
Fact of life.
Yeah, it's a fact of life. Yeah, exactly.
It's a document.
It's documented. I
It's a JavaScript issue.
The positive value of fit in a signed instrument.
yeah.
But there's no way to represent.
Yeah, like there's no sensible value to return aside from this one, so it's just something to be aware of. Or write property-based test. So let's revisit the 7 deadly sins and see whether property-based testing solve any of that. So I talked about, you tend to have a lot of coupling with your test data, and here you may reuse your generators for different properties, but at least you're not using the actual same values. You're just using generators that generate random values, right? But you're not reusing the actual values, so you've got less coupling already. Gluttony, so you don't need a bloated test suite. You have one behavior, right? One property. Okay. Am I doing on time, Dave?
How much time do you need?
Probably just 5 minutes.
5 minutes.
Is that okay? Okay. I know pizza is on everybody's mind, so yeah. Okay. So did I talk to? Yeah. So greed, you have become a slave to your code base. With property-based testing, you're less shooting for 95% or 99%. You're more focused on does this work for all the possible inputs to my function or my system or whatever, right? Is the API of my function or my unit or whatever you're considering, is the contract broken by some cases, or is it fulfilled over a range of values or over a large number of values? Sloth, so you can actually indulge in laziness. You leave the tedium to the library. You leave the library the hard work of generating random test cases. And that makes for more readable tests. So, I mean, simplicity is in the eye of the beholder, but I would argue, actually I've got an example at the end that I'll probably link to because I'm running out of time, but I find properties really easy to read, more so than example-based tests. And what's nice is that by not using particular values, you're raising the abstraction, the level of abstraction. So you're empowering yourself and the team to reason about your code at a higher level, okay? And it's less typing, more thinking, which is always good, right? Yeah. We already got too many tools that try to do our thinking for us, IntelliJ. Envy, so with this, the size of your code base, of your testing suite is tunable. So you can say, you can change one parameter, I won't do it here, but you can say it's 100 random values by default, but just for the crack, I'm gonna run 100,000, okay? And you don't have to do anything, all you have to do is change one parameter, so that's very powerful. And finally, your test suite has a high power to weight ratio, so it's small, and it's describing the truth, the whole truth, and nothing but the truth. So that's great. Cool. So I actually wrote an implementation. So I don't know if you know this guy, you recognize this guy, Kevin Henney. Great guy. A bit of a crazy hair, but it's very difficult to disagree with everything he's saying. I can't keep. I can't seem to be able to not nod vigorously when I'm watching one of his talks, so I definitely recommend. One of the recurring examples in his talks of an interesting data structure or an interesting abstraction to unit test is a recently used list. So if you use Safari, there's the reading list, and it works pretty much exactly like that. So if you've got an item in your reading list, if it's at the head, if it's at the top of your reading list and you add it again, it's not going to change your reading list. But if you've got an item already in your reading list, it's going to bump it to the top, okay? And you have no duplication, okay? You don't have duplicate items in your reading list. So it's an interesting abstraction because it's a bit of a stack, a bit of a set, a bit of a list. It's a bit all of that rolled into one. So it's an interesting abstraction to unit test, I guess, especially in a talk. So maybe I'll skip this. I'll link to my GitHub repo, and you can have a look, and you can send me feedback of whether you find my my suite of properties easy to read. Maybe if there are questions, I can show it. But okay. So very quickly, some common objections to property-based testing. Should I start using properties all over the place? No, because in some cases you really want to test just one value, and there's no random elements at all. I mean, you really want to test this one value, so a property in this case doesn't make sense. And then, oh, I can't think of properties about my code. So if that's the case, maybe you have a problem. Maybe if you're not able to extract general behavior about your system, maybe it highlights something more serious. And actually, property-based testing has been used in real systems. There's a talk about John Hughes, the father of property-based testing, about how he used it to catch very tricky race conditions in embedded software in the car industry. And it's actually used to, properties are used to check the soundness of the Scala compiler itself. And then, you know, the testing code starts looking more like production code. Is there not a risk of bugs lurking in there? And I would say that testing code has always been code, right? It's just that here it's at a higher level of abstraction. Like, you could still have bugs in your example-based tests. And Martin Fowler says the whole point is that they double check each other. Production code and testing code act as a double check, but it's not. One is more, has a higher claim as being code than the other. And then, oh, it's too complicated. So there's a notion that, you know, maybe it's too academic, maybe it's not pragmatic enough. Can I really use it in production? We use it in production to an extent. So, so if you're interested, and if you want to start playing with it at work, I'd say the easiest is to just do it sneakily and then try to sell it to the team. That's the way I sold it to the team. So it's easier to ask for forgiveness than for permission. So you go, I've written this. Have a look and see what you think. And the guys liked it, so we started using it. So in conclusion, properties are great. They raise the level of abstraction. They increase your confidence in the system and the test. They reduce the maintenance. And they give you more time to focus on what really matters. You don't want to be editing test data. You want to think about your system. Maybe you want to do some exploratory testing. Maybe you want to develop new feature. But, you know, all the tedium that comes with some testing based on examples goes away and leaves you frees you from doing the interesting stuff. So on that, it's probably best if I take questions over pizza. I'm guessing everybody's hungry, unless, yeah, I don't know.
Yeah, one quick question. Really, no people are hungry today. Cool.